In this video, we're going to look at drawing frequency diagrams and histograms. So the table below shows the masses of 120 apples. They're being classed according to equal widths, each of 5 here, and here is the frequency. This adds up to 120. It says draw a frequency diagram. It says a supermarket classifies the apples as given in the following table. Well, the size: extra small, small, medium and large. Extra small is between 50 and 52 grams. Small is 52 to 60, medium is 60 to 70, and large is 17 to 90. We know that there are 2 in the extra small group. It says copy and complete the diagram and draw A frequency diagram, and B, a histogram. Okay, so this is the original table, so you need to draw a set of axes going from 50 to 90, label the axes, and again we're going to need to go to at least 30 because the highest value here is 26. So what you need to do is draw in a bar, height of 8, a bar here, a height of 12, a bar of a height of 18, a bar of height 21, a bar of height 26, a bar of height 16, a bar of height 13, and a bar of height of 6. Now this looks fairly sort of normal. So it's a slightly out here, but it reasonably looks fairly normal. So the data appears fairly normal. Right, now we're asked to categorize the data. In the first one, this is 2. And because here there is 8, so there's 6 more to carry over into the next interval up to 60. So this will be 12 plus 6, which is 18. From 60 to 70, we will need to add together 18 and 21, which will give 39. And then the rest, or the 61, are all going to be considered from large. So we'll have to add these up. These out now add up to 120. If we draw a frequency diagram, so we do the same thing here. Mass of the apples, and here we have the frequency. If we draw a frequency diagram, the first one will only be height of 2. Pay attention to the scale. Next one will be a height of 18, 39, and then 61. Obviously, this looks very distorted. In fact, it's what's called as negatively skewed. So the data has been placed in unequal class widths. The distribution looks negatively skewed. This diagram gives a distorted view of the data. So one way to overcome this is to draw what's known as a histogram. So to overcome this, it is better to draw what's known as a histogram. So drawing a histogram, working out each class width first. So the first one is 2. This class width, 60 minus 52 is 8. Next one is 10, and then 90 minus 70 will be 20. Now the frequency density is what we need to do for a histogram. The frequency is actually proportional to the area of the bar. So the frequency density will be the frequency divided by the class width. So what you do to find this, you do the frequency, so it's going to be 2 divided by 2, which gives me 1. 18 divided by 8, which gives me 2.25. 39 divided by 10 gives me 3.9. And then 61 divided by 20, which gives me 3.05. So again, now we draw the same sort of axis along the bottom here, but now we only need to go up to 3.05. 3.9, so we'll probably need to go up to 4 on the frequency density. This axis is now known as frequency density. So if we now plot, the first one is 1. Again, the next one I need to plot is from 52 to 60. 52 to 60, and I need to go up to a frequency density of 2.25. Next one, I need to go up to 3.9 from 60 to 70. And from the last one, 70 to 90, I need to go up to 3.05. Now this looks more like the original data, not quite, but the data has now been split into unequal class widths, but now it has been fairly represented because the frequency is now proportional to the area of the bar. Now, sometimes you're given the problem in reverse. Say, for example, you're given the histogram and you have to come up with the frequency table. Well, you just need to work backwards. So you'll need to work out the width here. So the width here was 8 because it went from 52 to 60. And then the frequency density is 2.25. So working backwards, frequency will be frequency density times class width. So the frequency will be 8 times 2.25, which is equal to 18. So sometimes you're given the histogram and you have to come up with the frequencies. So you should know how to do that. Now, you should also bear in mind that the first diagram with equal widths is also sometimes called a histogram. This is particularly true if you do the IB, because the area of the bars is actually proportional to the frequency. If we work out the area of each one, that one's 40 because it's 5 times 8. This is 5 times 12, and we carry that process on. If we add those up, we get 600. And if we did 600 was represented by 120, so the total area divided by the total frequency will be 600 divided by 120. So each 5 units squared on here will represent a frequency of 1. So therefore the frequency is proportional to the area, so you could strictly call that a histogram. Though probably you wouldn't call this frequency, you'd now call this frequency density or frequency per gram. Okay, so this has been a video to show you how to draw histograms. I hope you've understood, and I thank you very much for watching.